All right, quadratic equation, section 1.7. So if you remember from your classifying polynomials, you know that quadratic equations have a degree of 2. So let's look at the different ways we have to solve these, okay? Because they're a little less straightforward than your linear equations, okay? So we can look at this first section here titled Solve by Factoring. Okay, and surprise, surprise, you're going to solve it by factoring the equation. Okay, an important thing to remember is you always need to, let's put this first. Red's good. Always set the equation equal to 0. Okay, so that means we're just going to get all the terms on one side so that the other side is 0. Okay, and the reason that we do this is actually kind of important. It gets lost on students a lot, but the reason we need to do that is because we need, in order to find a value of x, we're going to have to factor it to get a number times another number equal to 0. Okay, and the 0 property of multiplication or something like that tells us that for two numbers being multiplied together, for them to equal 0, either a has to equal 0 or this one has to equal 0. Okay, so we have to rearrange the equation so we have a number times a number, or a number times a number times a number. Basically what's happening is we're doing a bunch of multiplications. We have a bunch of factors being multiplied together to equal 0. Then we can set them equal, each of them individually equal to 0, and say, well, you know, if this value of x makes a equal to 0, then it will then the whole equation will equal 0. Okay, and that's what we're after here. So here we'll review your factoring rules, and it looks like this is going to be just a simple straight up trinomial factoring. Y and y, two numbers that equal negative 30 that add to 13. I'm thinking 15 and 2. The bigger one has to be negative since the 13 is negative, and the 2 will be positive. Okay, this is equal to 0. So this is what I'm saying here. Then we can set y minus 15 equal to 0 and solve for y, which is equal to positive 15, and then y plus 2 equal to 0, and y is going to be equal to negative 2 here. So we know that if we have either negative 2 or 15 here in for y, that will make this equation equal to 0. Okay, and that's what we want to solve. So using our set notation, y is equal to the smallest number first, negative 2 comma 15. And that is our answer. We have solved this equation. Okay. I'll do the last one. I'm trying to do the first and last of each section. So here we need to set it equal to 0. So 5p, so we'll subtract, let me take a step back. We'll subtract 4 from both sides, and we'll also subtract p from both sides. So we'll get 5p squared minus p minus 4. And then doing our slip and slide method, we're going to take this a and multiply it by c. Then we'll factor this p squared minus p minus 20. Looks like it's going to be 4 and 5. And the 5 has to be negative, 4 has to be positive. Then we're going to undo this division, or this multiplication here, by dividing both of these by 5. Okay, we see this is going to reduce to 1. This is not going to reduce, so we're going to take this denominator and move it up front. So now we have our factors are 5p plus 4, and sorry, that's equal to 0, and p minus 1 is equal to 0. Then we'll set each of these equal to 0 individually. So 5p plus 4 is equal to 0, and then p minus 1 is equal to 0. Here we have p is going to be equal to negative 4/5, and p is equal to 1. those are our solutions here. So p is equal to, in set notation, -4/5, comma 1. So pretty easy process once you get your factoring down quickly. Let's look at solve by square roots. So the square roots you're going to be able to do if you have perfect squares. Okay, so if you have and so this can be, this will probably look like a difference of squares, or you can also do if you have two squares being added to each other. But instead of factoring, we're actually just going to set the variable equal to the perfect square on the other side, and then just take the square root of both sides. Okay, so here we're going to move this square over to the other side, the constant over. So we have 16d squared is equal to positive 81. You can either take the square root of both sides now, or you can isolate the variable now. I'm just going to take the square roots of both sides, and we're going to be left with 4d is equal to plus or minus 9. Okay, and then we will divide each side by 4, so we'll have d is equal to plus or minus 9. Okay, so let's take a step back here and look at number 1 and number 4. We have two answers, right? The number of solutions of any equation is going to be equal to the degree. So the degree here is 2. We have two solutions. They're different numbers. But for number 5, our two solutions are just the positive and negative versions of the same number. Okay, and let's take a look to see if we would have factored this by difference of squares, what we would get. So factoring this side by difference of squares, we're going to have 4d plus 9 and 4d minus 9 is equal to 0. If we set each of them equal to 0 individually, we're going to get d is equal to negative 9 over 4. And then 4d plus 9, where we would get d is equal to, sorry, this is supposed to be minus 9. Then we get d is equal to positive 9 over 4. Okay, so now we have the positive version and the negative version. So you'll get the same answer by factoring difference of squares, or you can just take the square root of both sides if you have perfect squares. So d is equal to, we'll just say plus or minus 9 over 4. All right, let's look at, we might do a couple of these because there's a couple different situations I want you to be comfortable with. So here we can isolate m squared first. So let's divide by -6 on both sides. We get m squared is equal to -8. And then we'll take the square root of both sides. The square root of m squared is m. The square root of -8. Well, before we can do anything, we need to pull the negative out as I. So we'll get I root 8. And then we can write this as 4 times 2, right? So we get m is equal to, well, the square root of 4 is 2, so we'll pull a 2 out, 2i root 2. And sorry, this is going to be plus or minus here when we take the square root. And that is our final answer there. Number 7 is pretty straightforward. You're going to get a plus or minus. And then let's look at this one. So we have 10 minus 7s squared is equal to 1. We'll subtract 10 from both sides. We'll get -7s squared is equal to -9. We can divide here by -7. S squared is equal to 9 over 7. Let's take the square root of both sides since we're in the square root section here. We get s is equal to plus or minus. And then we have square root of 9 over 7. But let's separate this into the square root of 9 over the square root of 7, which will give us s is equal to plus or minus 3 over root 7. And then, because we cannot leave a radical in our denominator here, let me rewrite this. I'm just rewriting s is equal to plus or minus 9 over root 7. We're going to multiply the numerator and the denominator by root 7 over root 7 to rationalize the denominator, because we can't leave our final answer with a radical in the denominator. So we get s is equal to plus or minus 9 root 7 over 7. That is our final answer there. Okay, so a lot going on in these. We're kind of bringing together a lot of the skills that we've just been doing to solve these equations. Okay, so this is the point of working with the radicals and working with the rational expressions. We'll get to those a little bit later. So now we're kind of applying these concepts that we've been learning into solving different types of equations. Okay, so we've done solve by factoring, we've done solve by taking the square roots. Let's look at solve by completing the square. And here we get a little reminder on how to do these. So we're going to rewrite as ax squared plus bx plus c. Okay, this is a standard form. Okay, and then we're going to divide both sides by a. So we get, I don't even know what that means. Divide both sides by a, so it becomes x squared plus bx plus c. So we're looking, let me back up. This is not standard form. I looked at this wrong. We're rewriting this with c on the other side. So instead of it equaling 0, it's now going to equal c. And then we divide each of these by a. Okay, and now we have a leading coefficient of 1. So that's what we're looking to get to, is to have nothing in front of 1, and that be equal to some constant over here. Okay, so this c and this c are not going to be the same, and this b and this b are not going to be the same, right? They're going to be divided by a. Okay, so then we're going to complete the square by taking half of b, squaring it, then adding it to both sides of the equation. Okay, so you just follow that step by step. Take half of b, square it, then add it to both sides. Okay, and then you're going to factor the perfect square trinomial. Take the square root, and then solve both cases. Okay, so let's look at this a little in detail, because this is kind of a lot. So I'll leave the instructions up there. What we're going to do first is we're going to rewrite this as y squared plus 12y plus 20. I'm sorry, not plus 20. Y squared plus 12y is equal to negative 20. Okay, and then we would normally divide by a, divide by this leading coefficient here, but it's 1, so we don't need to worry about that. We can just skip to the next step. Okay, we're completing the square. We're going to take half of b, so b is equal to 12. Half of b is equal to 6. We're going to square it. 6 squared is equal to 36. And then we're going to add it to both sides. So now we have y squared plus 12y plus 36 is equal to negative 20 plus 36 is 16. Okay. Then we're going to factor this trinomial over here, okay? And this is a perfect square trinomial, right? We built it that way. We have two, so if we want to just factor it like the normal trinomial way, it'll be y, 6 and 6, and then you're adding them together, okay? But because these are the same exact binomial, we can actually write that as y plus 6 squared is equal to 16. Okay, so we just completed the square there, and now we have a perfect square, and it turns out we have a perfect square on the other side too. This is not always going to be the case, but it is right now. So then it's asking us step number 5 here to take the square root of both sides, and then now we take the square root of this, take the square root of this, we get y plus 6 is equal to plus or minus 4. Okay, this will create two cases because we have a plus or minus 4 on the right side there. now we're going to solve for each of the cases here. So y plus 6 is equal to 4, and y plus 6 is equal to negative 4. Okay, so I just split this plus and minus up into two cases here. Then we'll solve for each of them. So if we subtract 6, we get y is equal to negative 2. And if we subtract 6, that's a negative 4 here. It's kind of hard to see. We get y is equal to negative 10. Okay, so our solutions are y is equal to, in set notation, the smallest one first, negative 10 and negative 2. Whew, that was kind of a lot. Okay, so let's do another one together here. And then this is going to be a really long video, guys. I'm sorry. Excuse me. Let's do number 10. All right, so we're asked to do this by completing the square and write all answers in simplest form, okay? So the first step here was to rewrite this with all of your constants on the right side. So we have a negative 25 on the left side here, so we want to add that to the other side. So when we do that, we'll add 25 plus 25. Then we get 7b squared plus 14b is equal to, looks like 21. Okay. Then we're going to divide each of these terms by a, because we want to get b squared by itself. We don't want this coefficient up here, so we're going to divide each of them by 7. That will leave us with b squared plus 2b equals 3, which is nice and easy. Okay, we're going to complete the square. Now this is where we take b. b is equal to 2. We cut it in half, which is equal to 1. We square it. That's equal to 1. Then we add it to both sides. So we have b squared plus 2b plus 1 is equal to 4. Then we're going to factor this perfect square trinomial, which is going to be b plus 1. That is going to be squared. If you need to factor it as a regular trinomial first to see what it is and then combine it as squared, that's fine too. And then that's equal to 4. We'll take the square root of both sides. We're left with b plus 1 is equal to plus or minus 2. We'll set the left side equal to each of the options on the right. So b plus 1 is equal to 2, and b plus 1 is equal to negative 2. We'll subtract 1, b is equal to 1, subtract 1, b is equal to negative 3. So our solutions here are b is equal to negative 3 and 1. All right, so that's the solutions for that one. Let's look at one more, just because this is kind of a tough concept here, and I want to make sure you guys get it. So we're going to move this constant over to the right here. We get v squared minus 13v is equal to negative 12. Okay. We're going to take half of b, so b is equal to 13. Half of b is equal to 13 halves. Oops, that's 12. 13 halves. And then, sorry, that's not what b is equal to, but we're going to, so half of it is 13 halves, and then we're going to square it, which is 169 over 4. Okay, and then we're going to add that to both sides. So we have v squared minus 13v plus 169 over 4. That is equal to 12 4/4. 12 times 4 is what, 36, 64? 64... No, 24, 48, sorry. 48 over 4 plus 169 over 4 is going to give us, sorry, let me back up. I'm trying to rush so your video isn't so long. So we have it's going to be 169 over 4 minus, because this 12 is minus, it's a subtraction, minus, what did I say, 48 over 4, and that's going to give us 121 over 4. Okay, so this is going to equal 121 over 4. We're going to factor this side, okay, and we know that it's going to be v. So since this is negative, it's going to be minus, and then it's whatever this half of b is. So v minus 13 over 2 squared is equal to 121 over 4. Okay, then we take the square root of both sides. We have v minus 13 halves is equal to, 121 is a perfect square, it's 11. The square root of it's 11. 11 over 2, this is going to be plus or minus. And then we'll separate these into our two equations. V minus 13 halves is equal to negative 11 halves, and then v minus 13 halves is equal to positive 11 halves. We'll add 13 on the left side here. We'll add 13 halves to both sides. We get v is equal to 2 over 2, I believe. And then here we'll get v is equal to 24 halves, which is 12. Okay, so now we have our solutions. V is equal to 1 and 12. Okay, I kind of blew through that one, so make sure you take a minute here to do this and that you understand it. If you want more videos on this, I'm guessing there's going to be a lot of questions in these sections here, so just email me and I'll make more videos. It'll be easier to kind of split up there. Okay, so the last one here is going to be solve by the quadratic formula. What is the quadratic formula, you ask? Well, it is x is equal to the opposite of b plus or minus the square root of 4, the square root of b squared minus 4 times a times c divided by 2a. Whew. Okay, and remember this a, b, and c these are the coefficients of the quadratic in standard form. So you're gonna want to write in standard form so you know what a, b, and c are. Okay, so let's look at this one here. First is to write it in standard form. Let's just get everything on one side. So we'll subtract 10k from both sides. We get negative k squared minus 10k minus 8 is equal to 0. We want to get rid of this negative here. So let's just multiply both sides by negative 1. Keeps the equation true. And it basically just changes all of the signs on the left side. So we have k squared plus 10k plus 8. 0 times negative 1, still 0. Okay, so now we have a is equal to 1, b is equal to 10, and c is equal to 8. So let's write out a formula here. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. And then we're just going to plug in our numbers here. So x is equal to the opposite of b, so negative b would be negative 10, plus or minus the square root b squared, so 10 squared is 100, minus 4 times 1 times 8 divided by 2 times 1. So let's simplify the radical first. So we have x is equal to negative 10 plus or minus 4 times 8 is 32. And 100 minus 32 is the square root of 68 divided by 2. Let's simplify the square root of 68 here. Looks like we have 4. Let's look at factors of 68. What's 68 divided by 2? Obviously 34. So 68 divided by 4 is 17. So if we pull out a 4, that will be a 2, so we get x is equal to negative 10 plus or minus 2 root 17 over 2. We can divide each of these constants by 2 to simplify this a little bit. Negative 10 divided by 2 is negative 5, plus or minus 2 divided by 2 is 1, so we'll just write that as 17. Okay, and that's actually going to be our answer here. Since we can't simplify this anymore, it's negative 5 plus or minus the square root of 17. I will do this other one, this other example for you. So we're going to write this in standard form. So 6x squared minus 3x plus 9 is equal to 0. Our A is 6, our B is negative 3, and our C is equal to 9. So we have x is equal to negative b, so b is negative 3, so negative 3 is positive 3, plus or minus the square root b squared, so negative 3 squared is 9, minus 4 times a times c, so 4 times 6 times 9, that's divided by 2 times 6. Let's simplify these multiplications here. So we have 3 plus or minus 4 times 6 times 9. I'm just going to use my calculator here. 4 times 6 times 9 is 216. 9 minus 216 is equal to negative 207. So the square root of negative 207. That should be making a lot of you guys go, eek. It's the square root of a negative number. Okay. So before we do anything else, like always, we're going to have to take this negative out of the radical here. So we have x is equal to 3 plus or minus I root 207 over 12. 207, it looks like 9 times 23. Let me make sure. Yeah, 9 times 23, so we can pull the square root of the 9 out. And it will be 3 on the outside, so we have 3 plus or minus 3i root 23 all over 12. Then we divide all of these constants, this 3, and this 12, divide each of them by 3, we get x is equal to 1 plus or minus I root 23 over 4. I believe that is our final answer there. Whew, we've made it through almost all of this. Okay, and then this last question here is an application. So read the question here, solve the quadratic, get the answer. All right.